I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will learn techniques to simplify rational expressions. When we simplify rational expressions, we should also write the restrictions. If you do not include restrictions, then the two rational functions are not equivalent after simplification. Here are 4 questions starting from the very basic to a very complicated one. In this video, we will understand the strategies, the concepts, and then we'll be in a position to solve or simplify any rational expression, including the one which we have shown in question 4. I would like you to pause the video, answer this question, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
Now, let us take the solution of these one by one, starting with the simplest one, which is question number 1. The expression given to us is 2 times 4 minus x over x minus 4. I've already simplified it since I want to teach you one technique, and that is, do you see 4 minus x and x minus 4 are actually the same factors. The only difference here is that one is the negative of the other. So if I take negative outside and factor negative out, then I get x minus 4. Make sense? And I do have x minus 4 in the denominator. Now you can clearly see that they are exactly same, and so we can cancel them and write this rational expression as minus 2. You get the idea. So if you have factors which are placed like 4 minus x and x minus 4, when you cancel them, you do get a minus, right? You can also clearly see that the rational expression given to you, 2 times 4 minus x over x minus 4, is not exactly same as minus 2. What is the difference between the two? The difference is the restriction, and therefore, when we write this minus 2, we have to write the restriction, and that is that x is not equal to 4. You get the idea. So that is the restriction, x is not equal to 4, because at 4, this rational expression is not defined. So in case you sketch this rational expression, the graph of this may look like this. So here is our x and y axis. And in case you sketch it, at 4, there won't be any valid value. It will be represented as a whole. So the function can be shown as a horizontal line and at 4 a whole. So that is what the function is, right? And this point here, which is shown to you as a whole, corresponds to the restriction, where at 4 we have a value of minus 2. Does it make sense to you? So this is a very important concept which I wanted to specify and make absolutely clear before moving forward. So whenever we have restrictions, in that case, we could have either a whole or a vertical asymptote. When the factors cancel, we have a whole as shown here. Correct? Now this green line which shows with a whole, represents our rational expression. Perfect? Let's now get into the real process of simplifying rational expressions and then writing the restrictions. Important thing here is that restrictions should be written before cancelling the common factors in numerator and denominator. Now, let us see this one. X squared minus 5x plus 6 over x squared plus 3x minus 10. So you need to factor both numerator and then denominator. So let's say we have x squared minus 5x plus 6. Now you can apply product and sum. 6 is the product of two numbers p and q. So we say p times q equals to 6. And when we add them, we should get the coefficient of x, which is minus 5. Now since after addition you have a negative number, then the bigger number should always be negative, correct? And in this case, product is positive, means both are negative, right? So 6 is 3 times 2, and 3 and 2 when added will give you 5. Both negative will give you minus 5. And therefore, I could write this as x minus 3 times x minus 2. Make sense? Now let's look into the denominator. The denominator part is x squared plus 3x minus 10. So we're looking for product of minus 10 and sum of 3. The two numbers are of different sign. Greater is positive, right? So 5 times 2 work, and therefore I could write this as x plus 5 times x minus 2. Perfect? And that means that I can now rewrite my given expression in the factored form. So let us now rewrite the expression in the factored form, and we can say the expression here is the numerator x minus 3 times x minus 2 and the denominator as x plus 5 times x minus 2. Now you see, you could cancel x minus 2 and x minus 2 to simplify. And once you cancel, you can rewrite this as x minus 3 over x plus 5, correct? But don't forget to write the restrictions. The restrictions are the cancelled factor, which gives you a whole at x equals to 2, and the factor which remains gives you a vertical asymptote at x equals to minus 5. So these are the restrictions, and they have their own significance. So when you learn sketching rational expressions, you will appreciate this more. So I hope these steps are clear, right? Let's take up the next example. In fact, this is very similar to what we just did. So I'd like you to factor the numerator and denominator and then simplify and write the restrictions. So let's begin with the numerator, which is 2x squared minus xy minus y squared. Product and sum. The product is 2, right? So the product of the 2 should be 2 and the sum should be minus, right? In fact, I should write 2y squared, right? Since y squared is there and the sum p plus q should be minus y. You get the idea? Because this time we have introduced two variables. So in that sense, this rational expression is slightly different from one which we had taken earlier. However, the technique is exactly same. Now, how do you get 2y squared as the product and minus y as the sum? Well, minus 2 times 1, right? So that should work. So we basically split minus xy. So we could rewrite this as, let me rewrite this as 2x squared minus 2xy plus xy minus y squared. And now you group factor, taking 2x common, you get x minus y. And we have y common, and factor is x minus y. Since x minus y is a common factor, the other one is 2x plus y. So that is how we have factored this one. Now let's look into the denominator part, and the denominator part here is x squared minus 2xy minus y squared. Many of you will remember that this can be factored as x minus y whole square, right? So I'm not getting into that detail. I'm straight away writing the factored form. Now factoring is a technique which you should definitely know before getting into simplifying rational expressions. You may have to review these techniques if needed. Okay, now let us write down the solution. So the given expression, which is 2x squared minus xy minus y squared over x squared minus 2xy minus y squared, can be written with their factors, which is x minus y times 2x plus y divided by x minus y whole square. So clearly you can see that x minus y can be cancelled, and so we get our simplified form, which is equal to what? 2x plus y in the numerator divided by x minus y in the denominator. The restrictions here is that x is not equal to y, since both the factors in the denominator were y, right? So that is how we will do this one. That brings us to the last question, which is kind of complicated. We have layers of rational expressions, just as we work with layers of fractions, you understand. So this time there are 4 to factor. Correct. So this could be written as, let me rewrite this, as 4x squared minus 16y squared over x squared minus 3xy plus 2y squared times, now division is reciprocal of multiplication. So you could rewrite this as I am writing. So the denominator now flips, and we are going to multiply this with x squared plus 2xy minus 3y squared over x squared plus xy minus 6y squared. Makes sense. So that becomes your factored, that becomes your rational expression, which need to be factored, then simplified, and then you need to write it with restrictions. Get the idea, right? So can you please do it? Okay. So the numerator you can see is 4x squared minus 16y squared. That can be factored. 4 common, you get x squared minus 4y squared, and that can be factored, correct? So let me show you this, right? So first one is 4x squared minus 16y squared, right? So this could be written as 4 common, and we have x squared minus 4y squared. Now this could be factors at difference of squares. So 4 is common, and we have x plus 2y times x minus 2y, right? So we use difference of squares for the first one, correct? Now the next one, x squared minus 3xy plus 2y squared. Now to get 2, it is 2 times 1, both negative, right? So I could have written this also very easily. So we can write this as, so let me write the whole expression in the factored form, correct? So I can write the whole expression as what? Let me rewrite this here. So the numerator, just which I showed you, is what? It is 4 times x plus 2y times x minus 2y, correct? Now this denominator, x squared minus 3xy plus 2y squared, we are looking for a product of 2y squared, sum of minus 3y. So 2 times 1 can work, and therefore x minus 2 times xy, right? So that works, right? So 2 and 1, both negative, right? So x minus y. Makes sense? And the other factor in this case, we have minus 3y squared, right? Not 2, but 3y squared. So 3 times 1, right? But 3 is positive, so that will be x plus 3y times x plus 1, correct? And the denominator in this case will be, here we have minus 6y squared plus 1, 3 times 2, right? So it could be 3 times 2. So x plus 3y, and 2 will be negative. This is y, right? Sorry. Minus 2y, correct? So these are your factors. Perfect. I'd like you to pause the video, check that these are the right factors. Perfect. Once you've done that, then you can cancel the factors which are common in numerator and denominator. So this one cancels. X minus 2y cancels. And what else? So x plus 3y also cancels, right? Okay. So we are remaining with x minus y, x plus y, x minus 2y. Okay. So that is what remains. And therefore, we can now write this as 4 times x plus 2y times x plus y over x minus 2y times x minus y. Clear? And we have to include the restrictions. Everything which made 0 for the denominators, and when we divide, because the whole fraction comes in the denominator, the rational expression, we have to consider both numerator and denominator for these. So here, x is not equal to 2y, and then we have y here. Here we have minus 3y. Here we have plus 2y. So that is common. We have taken care of minus 3y and minus y. Do you see that? So we have to take restrictions from all these factors highlighted. They should not be 0. Correct? Because these two were in the denominator. So these 3 we have to consider for restrictions. And that is kind of important to understand at this stage. So we have simplified the rational expressions with layers of polynomials. And we have clearly mentioned their restrictions. The restrictions which cancel with numerator and denominator may lead to wholes, and those which do not cancel and remain till the end are representing the vertical asymptotes when the rational expression is graphed. With that, we come to an end of this exercise of understanding how do we simplify the rational expressions and write them with restrictions. We learned the technique of -1 could also be taken as a factor, and then product and sum was the standard way of factoring. Also, we had an example with a perfect square. I hope it makes sense. In case you want to learn from me, you can always send an email on the address given. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.